An aerial, wall robotic insect that can land, climb, and take off from vertical surfaces, published by Research. Professor Ai Hongji's research team at Nanjing University of Aeronautics and Astronautics, Nanjing, China has recently developed a bionic robot with flying and climbing ability that can complete smooth movement, including landing on a vertical wall, climbing along the wall, and taking off from the wall. The robot insect adopts a flapping or rotor hybrid power layout, which realizes not only efficient and controllable flight in the air, but also attachment to, and climbing on, the vertical wall. The attachment and climbing motion are through a synergistic combination of the aerodynamic negative pressure adsorption of the rotor power and a climbing mechanism with bionic adhesion performance. The longitudinal axis layout design of the rotor dynamics and control strategy realize a unique cross-domain movement during the flying-climbing transition. In order to optimize the flying-climbing transition scheme of bionic amphibious robot, several pretests have been conducted. The flying-climbing transition process is closely dependent on the hybrid layout design and requires coordinated control of the actuators. The robot insect provides sufficient control force and torque. The net vertical thrust of the flapping or rotor hybrid power, when actuated, maintains an approximately linear relationship with respect to the throttle command. The team quantified the transition performance of the robot insect. The robot can perform continuous and complete air-wall-air transitions in 6.1 seconds. It enables the robot to cross the air-wall boundary in 0.4 seconds, landing, and cross the wall-air boundary in 0.7 seconds, taking off. The climbing speed on the vertical wall is 6 cm per second. The ground takeoff and landing experiments demonstrate the unassisted takeoff, hovering, and yaw movement capabilities of the aerial, wall robot with the support of onboard electronics and power supplies. The aerial, wall robot has successfully demonstrated its ability to land, climb, and take off from a variety of complex vertical walls, including glass, wooden door, marble, tree bark, elastic cloth, lime wall, and painted iron sheet. This series of steps is very common in nature. For instance, when a cicada arrives at a location after flying some distance, lands on a wall, climbs to a place where it feels comfortable, and then flies to the next place. It has important implications in understanding the takeoff and landing of insects.